Okay, so I'm going to go over the written part of Exam 1, kind of talk through some of the problems to discuss how I would approach them, and then you'll see on the screen also kind of my worked out version, and there will also be um, a PDF of that connected as well. Um, so if we flip to page 1, or to problem 1, it's got 3 parts. Each of these parts is 5 points. Um, So if it was a minor error like a 7 turned into a 2 or something like that, just being sloppy, that'd be 2 points off. If it's some type of major error that seems like you don't know what was supposed to happen, or like your place value or something like that was off, then that's going to be -4. And if you just have an answer with no work, that's probably going to be 3 points off because you were you were told to show your work. All right. So we've got 1A is 34 times 47. So you can see I have two different ways of doing this. On the left, you've got it written vertically, and those steps kind of go out where you've got the 34 times 7 at first, and then the 34 times 4, but shifted over to the tens place, and then you put those pieces together. Um, the version on the right is what I like to use as kind of a lead in to more algebraic ways of multiplying, kind of the distributive property where you got 30 plus 4, and then each of those squares represents the number to the right, or sorry, the number to the left or the number on top multiplied, and the number on top multiplied together, and then you add up the squares. Uh, so that's pretty clear on that. On B, we have 4,563 divided by 8. Um, here we did kind of a long division form. We find, well, the 8 doesn't go into 4, so then we move to the 45. 8 goes into 45 5 times, that's 40, and so 8 times 5 is 40, so you're taking away 40 of those 45, you're left with 5 of them. Then that's good, it's less than 8, so you know 5 is a good number. We're going to drop the 6 down from the tens place, so now we have 56. Well, 8 goes into 56 7 times exactly, so we have the 56 subtracted from 56, and that gives us 0. So then we have 0, we drop the 3 from the ones place, now we have 3, 8 doesn't go into 3, so that's why we're at 570, but we have that 3 remainder. And since we're asked to put it in quotient and remainder form, we have 570 remainder 3. On C, 1C, we've got -2 minus -12 plus 7. Hopefully at this point you remember that when you're subtracting a negative, it's kind of like adding. These are all, you have subtraction and addition in this problem. Those are on the same level, so we just start left to right and go through like that. So if I've got -2 minus -12, I'm subtracting 12 negatives from -2. So I'm not going to have any negatives left. In fact, I'm going to have to kind of borrow some from the zero pairs. So I'm going to end up with +10 because I've taken away a lot of negatives, more than I had to start with. So I'm in the positive side now. And then so I have +10, then +7 more. So I had 10 positives plus 7 positives, so now I have 17 positives. And hopefully that makes sense. All right, so let's go on to number 2. Okay, just so the note is there, he says you must algebra to solve this problem. I think you must use algebra to solve this problem. And make sure you define the variables. Some of you are not used to defining variables, so try to do that. So it says, in a bag of marbles, there are 3 times as many blue marbles as red marbles. If there are 24 more blue marbles than red marbles, how many marbles are in the bag? So here we're led to assume that we have blue marbles and red marbles, and they're both in the bag together. And that's all that we have in the bag. So here I say, okay, I'm going to say B is equal to the number of blue marbles, R is equal to the number of red marbles. If you got that kind of setup or something along that, then you define the variables. That's worth 2 points. All right, so now I'm going to change my kind of sentences here into algebraic equations. So B, the number of red marbles. The first sentence, so I put it second, B equals 3R. So B, the number of blue marbles, is 3 times as much as R. If you took R multiplied by 3, you'd get the blue. And then the second sentence, which I have on top of that equation, is B equals 24 plus R. So that means it says 24 more blue marbles than red. So if you take red, you add 24 to it, you get up to the amount of the blue. Now these two equations I'm going to use to solve my problem. I have 2 variables and I have 2 equations, so I have a good chance of being able to solve this. So then I go ahead and say, okay, well, I know that each of these things are equal to B. So I'm going to replace one of the B's with one version of the R thing. So, for example, if I take the upper equation, B equals 24 plus R, and instead of putting B, now I put 3R, we know that they're equal, so we can replace that. So 3R equals 24 plus R. And then I get my R's to the same side. I can take off an R from each side to remove it from the right-hand side. Then I have 2R equals 24, so half of that means R equals 12. So here we're in good shape. Now that we know R equals 12, I can put R back into one of the others, and it should work for both of them. So if I do 3 times 12, which is R, then I get 36. That's the one I wrote down. But also if I do 24 plus 12, I also get 36. So now I have 36 and I have 12. And remember, we're asked what the total number is. So in this case, the total number is the 12 red plus the 36 blue. And that gives us the total of 48 marbles. All right, number 3. This is 2 parts, so each part's worth 5 points. Here we have 2x divided by 3 equals negative 14. If I so since the 2x is being divided by 3, I'm going to undo that by multiplying. So I multiply both sides by 3. So 2/3 times 3 ends up being 2. That's why we used it, because we wanted to eliminate that divided by 3 part. So we have now 2x equals negative 42. That's the 3 times negative 14. Then of course that's 2x, but I want to figure out what only 1x is worth. So I divide by 2 on both sides and I get, and that's negative 21. Okay, so you can see kind of the minor error, major error, and if you just gave me an answer with no work, what that would be like. Okay, and then let's look at the next one. Obviously here we're going to need to use the distributive property. So we've got negative 5 times the quantity 2x plus 6 equals 2 times the quantity x minus 1 plus 8. So I'm going to distribute this negative 5 on the left side. So I've got negative 5 times negative 5 times positive 2x, so that's negative 10x. Then I've got the negative 5 times the positive 6, that's negative 30. Now I'm going to distribute on the right side. The 2 times the x, 2x, and 2 times negative 1, negative 2. So now I have 2x minus 2 plus 8. I still have that plus 8 left over. And then, so after that, we're going to try to get all the x's together on one side, get all the things that don't have x's, all the terms that don't have x's on the other side. So I add 30 to my left side and my right side. Add 30 because the negative 30 plus 30 is going to go to 0. So that kind of gets that taken care of. So I add 30 to both sides. I'm going to subtract 2x from both sides because since I'm shifting my numbers without x's to the right, I want to take the x terms that are on the right and move them to the left. So I subtract 2x from that side, I subtract it from the other side. I had negative 10x, then I subtracted 2 more, so I'm even farther on the negative, so I'm negative 12x now, and that equals 36. I'm dividing by negative 12 because it's being multiplied to the x, so I undo that by dividing. And if I do it to the left side, I've got to divide by 12 on the right side as well. So negative 12 divided by negative 12 is positive 1. 1 times x, then of course it's just x. And then 36 divided by negative 12 is negative 3. All right. And now number 4. All right. So it says evaluate the following. A and B are each worth 5 points. You got a similar grading scale. In this case, what I like to do is before I substitute in, I put parentheses in place of any of the variables or unknowns. And so here first I have 3 times the quantity, and then I put in parentheses negative 2, which came from the s, and then squared, plus 2 times in parentheses, which came from the t, negative 1, and then the minus 1. Negative 2 quantity squared. The squaring goes to the parenthesis, which means everything inside the parentheses is multiplied by itself. So that's negative 2 times negative 2, which of course then is positive 4. So now I have 3 times positive 4 equals 2 times negative 1, which is negative 2, minus 1. So now I have 3 times 4, which is 12, minus 2, minus 1, which is, now I can move simply left to right. 12 minus 2 is 10, and then I have the minus 1, so that gets me to 9. All right, on 4b, we have 12 minus 3 times negative 4 divided by 4 divided by 2 times 3. So I'm going to take care of the numerator and take care of the denominator separately at first, and then work it back together. So I have 12 minus, then I have this multiplication. The multiplication has to be done first before I can do the subtraction. So I have 3 times negative 4, that's negative 12. Now, so in the numerator, on the top I have 12 minus negative 12. So I'm subtracting a negative, that's like adding, so now I have 24 in the numerator. Now let's go back to the denominator. I have 4 divided by 2 times 3. Division and multiplication are both on the same level in the order of operation, so I'm moving from left to right. These happen to be grouped, so I also know that I'm doing the grouping first, which happens to be the same thing. So in this case I have 4 divided by 2, which we know is 2, then multiplied by 3, so that's 6. So now overall I have 24 divided by 6, and that's 4. Okay, for number 5, we have translate the following sentence into an equation. Do not solve the equation. You don't have to solve it, you just have to set it up, make it a mathematical statement from this English sentence. So the sum of 5 and, so when you hear sum, you should be thinking I'm adding 2 things together. So 5 is one of the things I'm adding, and the next thing I'm adding is 3 times a number. I don't know what that number is, so I'm going to give it a variable. In this case, I gave it x. So 3 times a number. So now you see on the left I have 5 plus 3x. The sum of, that's the adding, 5, which is one of the things I'm adding, and 3 times the number is the other thing I'm adding, is equal to, obviously I put an equal sign, the square of that number. So whatever variable I used before, this case an x, I need to use again. And I'm squaring it, the square of the number, less 4. Remember when I said, if it says less, think minus. If it says less than, think subtracted from. So less and minus are both one word. Less than and subtracted from are both 2 words, so you can kind of keep that in mind. So I could read it as the square of that number, the square of x, or x squared, less minus 4. So x squared minus 4. And that's how I developed that equation. All right. So hopefully that gives you a little better sense of how those problems work together. If you still have questions, make sure you ask me.